If you are trying to build software today, your daily engineering workflow has likely reached a complete breaking point. Your discussions happen in Slack, your issue tracking is in Jira, your codebase sits on GitHub, and your AI assistant is isolated in a separate window. Navigating this tab soup demands constant context switching. Every time an engineer jumps from a pull request to a chat thread to a prompt, they lose a fraction of their focus. Over an entire sprint, this friction compounds into a massive drain on productivity. This setup also severely limits large language models. Confined to isolated interfaces, current AI tools operate like blind code vending machines. They answer specific prompts, but they have zero awareness of your team's internal history, past architectural debates, or the specific conventions of your Git repository. Curious, engaging, Jack Dorsey and his company, Block, recently released a project aiming to solve this exact problem. It is an open-source platform called Buzz, and it proposes a workflow where AI agents sit in the exact same digital room as human developers. The project operates on the theory that shared context between humans and autonomous systems is the missing link in modern software engineering. Buzz achieves this by physically merging a team chat interface directly with native Git hosting. The entire platform is built on Nostr. Nostr is an open, decentralized protocol using a network of independent data relays to transmit messages. It is important to note that Nostr is a protocol, not a blockchain. There are no tokens or mining involved. Buzz uses this layer to enable what Block calls agent multiplayer. The workspace is model agnostic, meaning you can plug in Claude, run OpenAI models, or local open weight models in the exact same channel. To prevent chaos, Buzz introduces the concept of a cryptographic passport. Every human and every AI agent on the platform generates its own unique Nostr key pair. When deployed, the agent's identity connects securely to the human owner's master key. This creates a strict dual signature system. Every time an agent writes code, the action is mathematically stamped with both the agent's and human's key. If a rogue script deletes a repository or introduces a vulnerability, the audit log proves exactly which machine executed the command and exactly which human authorized that machine to run. To see how this architecture functions in practice, we can look at a recent test running a competitive coding challenge directly inside a Buzz instance. The test placed two different language models into a single shared coding channel. One agent, given a strict persona, ran on Gemini 3.6 Flash. The competing agent was powered by GLM 5.2. Both were tasked with building a complete authentication system from scratch. The agents acknowledged the prompt and immediately went to work. They wrote the application code, generated the necessary files, and opened their own individual feature branches directly within Buzz's built-in Git host. Once the initial code was pushed, the agents actively started reviewing each other's work. They identified security vulnerabilities in the competing branches and engaged in a heated debate over NPM package safety right in the main chat interface. These results demonstrate an active engineering partnership. The agents autonomously write, review, and document their work alongside their human counterparts. This brings us to the macro-level philosophy driving projects like Buzz, the sovereign AI movement. This is a deliberate rejection of reliance on closed-source, centralized tech monopolies. When your engineering team relies on standard cloud tools, you are effectively paying rent with your data. You surrender your internal chat history, your intellectual property, and your workflows to centralized servers controlled by third parties. Because Buzz is fully open source, a company can self-host its own Nostr relay and run local AI models on its own hardware. All code, prompts, and team discussions remain entirely within the organization's firewall. By utilizing this stack, organizations reclaim absolute ownership of their data. They are prioritizing complete control and data sovereignty over the plug-and-play convenience of standard commercial tools. However, there is a stark reality check required here. Buzz is currently sitting at version 0.4. It is a technical preview, and Block clearly states it is an unfinished product. Choosing to self-host this infrastructure today means you are taking on the immediate operational burdens of an IT department. Your team becomes solely responsible for server maintenance, data backups, and network security. This line graph shows the severe financial risk of unmonitored API integration. In an environment where multiple AI agents operate autonomously, bots can quickly start talking to other bots in a continuous loop. Without strict limits, this runaway feedback loop will drive token consumption exponentially upward, draining your budget in hours. Buzz provides the foundational blueprint for agent multiplayer. It proves that a verifiable owned history is necessary for humans and AI to coordinate effectively as autonomous tools take on more complex work.